All right, y'all. We are looking at the 1-8 notes talking about absolute value inequalities. Okay, I want to start off by saying that this section of notes right here, almost exactly the same as the ones from 1-7. Okay, 80, 85, 90% of the work that we're doing in this entire section is exactly like we did yesterday. But there are a couple of important things that are different. Okay, I want to go ahead and look at the stuff on the front page of the notes right here that points out what is different about it. Okay, first thing is obviously the word inequality. Okay, the word inequality is telling us that we are not dealing with an equation. Okay, we're dealing with something that doesn't have an equal sign. It's going to have one of these. It's going to have a greater than or a less than instead of an equal sign. Okay, what that means for us is that there is something else attached to our answers. Okay, either the word and or the word or will be part of our answers when we describe our solutions today. Okay, so you're going to see how a lot of it is very similar. You're going to see how a lot of it is very different from that previous section that we did of absolute value equations. Let's jump in on the first example. Okay, something that is the same as our previous section is that the first thing we need to do is get this part completely by itself, okay? Something that's going to be true for all of our absolute value problems is that we need to get the absolute value part, the actual, the part inside those absolute value vertical bars. That is the part we need to have completely by itself on one side of the inequality, okay? So we need to get rid of the minus 10 that's at the end. How do we do that? Well, we add 10. Remember your golden rule of algebra. What you do on one side, you must do to the other side. Okay, so we go plus 10 on both sides. We have the absolute value set up there by itself now. That negative 5 plus 10 turns into positive 5. And now we have the absolute value completely isolated, which is what we were going for. Okay, this is the point yesterday where we split into the positive and negative version. And we're going to do that same thing again today. Okay, we're going to split in the positive version right here. Positive 5. And we're going to split in the negative version. Negative 5. Something I want you to notice is that from our original to the positive version, we kept the same sign. But when we went to the negative version, we flipped it around. Okay, that is one of the rules that we have to keep up with that's different from yesterday, is that we have to keep up with when we do the split and bring up the negative version of this, we have to flip that sign around. Okay? Solving to get x by itself turns out to be pretty simple. We're going to add 3 and then divide by 2. In the negative version, we do the same thing. We add 3 on both sides. Remember that golden rule. And then we divide by 2. Now, look at our two answers, okay? Our two solutions, we have x is greater than 4 and x is less than negative 1. I want you to think about those two groups of numbers, okay? I want you to just pick an example, okay? Pick a number that is that fits into this blue inequality right here. Okay, if we pick a number that fits into that blue inequality, we could say that the number 7. Okay, we could say that 7 is greater than 4. Okay, that 7 is a number that fits for x right there. Does 7 fit into the other inequality? Okay, is 7 less than negative 1? And the answer is no, of course it's not. Obviously, 7 is not less than negative 1. Okay, but let's look at it the other way. Okay, let's pick out a number that does fit into the red inequality. Let's say negative 2. Negative 2 is less than negative 1, but does negative 2 fit into the other one? Negative 2, is that greater than 4? Absolutely not. No chance. That doesn't fit whatsoever. What this tells us is that these two groups of numbers, these two inequalities, are completely exclusive of each other. Okay? It is not possible for any number to fit into both of those categories. So what we put in between our two solutions is we put the word or. okay, all of our solutions that fit into our original inequality that we just solved from up here at the top, all of the numbers are either greater than 4 or they're less than -1. Okay, that's what that word or means. Now, if you're thinking about it in those ways, if you're thinking about it as do those two groups of numbers overlap at all, that can get pretty confusing. So the way that we know if it's going to be the word or the word and is by looking at the sign. Okay? When I talk about the sign, I mean when we get the absolute value isolated, we look at this thing right here. And if it's greater than, we're going to use the word or to join our answers. And if it's less than, we're going to use the word and to join our answers. Okay, that's what actually we had highlighted on this front page. If we have a greater than after, and this is after the absolute value is isolated. Okay, I do want to emphasize that. The first step where you isolate the absolute value, get it completely by itself, that is still the first thing that you do. But after you've done that, you can figure out if it's going to be an or an and in your final answer. Okay, this one, after we had it isolated, it was greater than, so we have an or that joins together our two answers right there. Go on down to our next example. Okay, once again, the first thing we need to do is get this absolute value part completely by itself. So how do we do that? We got to get rid of that coefficient. It is very tempting to take that coefficient and multiply it inside of there and turn it into 8x plus 4. Do not do it, okay? We do not distribute inside of absolute values. To get rid of a coefficient, we have to divide it out of there. Okay, we have to divide it. We get the 4x plus 2 absolute value by itself. When we divide by 2, that gives us positive 5 on that side. And then we split it. Okay, actually before we split it, let's look at that symbol. Okay, this symbol right here is a less than. That tells us when we get to the end, we're going to have the word and that joins our two answers together. Okay, so now let's split it. We have the absolute value completely isolated. The positive version looks like this. 4x plus 2 less than 5. The negative version, 4x plus 2 greater than -5. Okay, remember you got to flip it around when you do that split. Okay, then we just solve it to get x by itself. Subtract 2. And divide by 4. Same thing on the other side. Okay, it works both ways. We subtract 2 and then divide by 4. All right, we decided up here at the top that was a less than sign. That means we're going to use the word and. So that's what we put right here. Okay, if you were thinking about why we used or on the last one and why we used and on this one, I want to take another example, the number 0. Okay, the number 0 is something that definitely fits into the blue inequality that's on the screen right there. 0 is definitely less than 3/4. But also, 0 is greater than -7/4. That's -1.75 if you're looking in decimal form. Okay, 0 is definitely more than that, but it's less than the blue one. That tells us that 0 is a number that fits both inequalities. Okay, that tells us there are numbers that overlap and they fit the first inequality and the second one. Okay, since there are some numbers that overlap and fit both of them, that's how we know we're using an and right here. Okay, that's how we know we are looking at that overlapping space of those two inequalities. Okay, the first one and the second one. Now you can see from those two examples that most of the work today, like 90% of it, is exactly like we did yesterday. Okay, there's a couple little things you got to watch out for, like turning the sign around when you do the negative split. And there's a couple little things like looking out for if you're going to do an and or an or. But also, like yesterday, we have some special situations, some certain special cases of what these problems could look like, okay? Part A down here at the bottom is one that we actually talked about yesterday, okay? When we talked about absolute values, we said that the absolute value, the definition of that is that it is the distance between a number and zero when you put them on a number line, okay? And we talked about distance, and we said that it doesn't make sense to say that I'm negative 3 feet away from this table. It doesn't make sense to say that I drove negative 4 miles down the road. Okay, a distance is always a positive number that gets traveled. Okay, I'm 3 feet away. I drove 4 miles. That's always a positive number when you assume that. Okay, so how does it make sense if an absolute value is a distance? How could you have a positive number right here equal to a negative number? And the answer is it doesn't make any sense. So when we had a situation like this where the absolute value was by itself equal to a negative number, we said there was no solution. That's the little symbol that we put on all of those. If there were any that had an absolute value equal to a negative, we said there was no solution because that's not possible. Okay, well look at part B. Part B and C are dealing with inequalities. They've got greater than and less than signs instead of equality. So that means on part B, we've got a positive number right here. Remember, your absolute value is a distance. It's not going to be negative. How is it possible that a positive is less than a negative number? Once again, the answer is it's not possible. So that tells us that this right here, there is no solution, just like those ones we talked about yesterday. A positive number can't be less than a negative. Positive 1 could never be less than negative 10. Nothing even more than that could ever be less than negative 10. So there's no solution for a problem like this. Look at part C though. Part C tells us that a positive number is greater than a negative number. Hey, think about it this way. Positive 1 is greater than negative 10. Positive 1 billion is greater than negative 10. Positive 10,008 is greater than negative 10. It does not matter what x value you try and plug into this inequality. Every single time, no matter what, it is always going to fit in that inequality where a positive number is greater than a negative number. That tells us that our solutions right here are all real numbers. Okay, that's that symbol. You've seen it before, the R with two stems on it. All real numbers. Any x value could fit into that. The way we've been talking about all real numbers, we've said negative infinity up to positive infinity. That interval represents all real numbers. Okay, it's the same thing. All right, so as you're working on these problems, don't forget the rules for how you would solve an inequality. Okay, don't forget about those situations that change when you're doing an inequality versus when you're doing an equation. Okay, one thing I want to point out in particular is when you get to this problem right here. This is problem number 2 on your homework assignment. Be careful of what happens to a greater than or less than sign when you divide by a negative number. Okay, you have to flip that sign when you divide by a negative number. Same thing when you get to number 8. Okay, this is problem number 8 from your homework. Make sure when you divide this part and get it by itself, make sure you are flipping this sign around when you divide the negative 6 away. All right, that's all I've got to say about that. That is all of the notes for today. Y'all have a good one.